So I want to do an example with you where we have variables on both sides of the equation. So even if you are comfortable with recognizing that there's two sides of the equation, I'm still going to put this line in here for those of you who are still struggling with that concept. So since we have a negative 4x on the left side and a 3x on the right side, we have to get the variables to one side. So if you remember our don't call me after midnight acronym, you want to ask yourself, is there any distribution? Well, I don't see any parentheses on either side of the equation. So then we go to C, which is combine like terms. We cannot combine negative 4x and plus 6 on the left side, nor can we do 3x minus 36 on the right side. So our next step would be to move the variable to one side. So you have the choice. You could move this negative 4x to the right side, or you could move this 3x to the left side. I'm going to show you both ways, but I'm going to tell you why I prefer moving the negative 4x to the right side. If I do this, and I add 4x to both sides, I'm not really dealing with negative numbers now. So I'm going to bring down everything else that I didn't use. I have 6 equals 7x minus 36. And now this looks like an equation that you would know how to solve. So to get this 7x by itself, I still have that negative 36 hanging out with it. So I'm going to add 36 to both sides to give me that 0 or that 0 pair. And this side would cancel out. On the left side, I would get 42. Bring down the rest of it that we did not use. So how would I solve for this? Divide both sides by 7. This gives me 1, or 1x, which I want, and the left side would give us a solution of 6 equals x. Let's try and solve it the other way. I should still get my solution to be 6, just like in the last way that I solved it, but this time I'm going to move the 3x to the left side. So if I do that, I would be subtracting 3x on the right side, subtracting 3x on the left side, and this side would cancel out. I would now on the left side have negative 7x plus 6 equals negative 36. So as you can already see, if I did this, the smaller number between negative 4 and 3 on the number line, negative 4 is smaller. That's why I moved it to the other side, because now this way I'm dealing with a negative 7, which is okay, but if you're somebody who's not so strong with using negatives in your operations, I would always suggest that you try to move the smaller number to the other side. So now, if I'm trying to get this negative 7x by itself, I have this plus 6 that's hanging out with it on the left side. So in order to get rid of that, I'm going to do the inverse. Minus 6 to both sides. That 6 now cancels out. And now I'm left on the left side with my negative 7x equals a negative 42. My last step would be to divide both sides by a negative 7, so I get the x by itself. That would give me the 1 that I want, and I would get x equals a positive 6. The same solution the other way that we got in the other problem. Okay, now if we look at number 14 on this page, I have another problem where there are two variables on both sides of the equation. So there's an x on the left, there's an x on the right, and we have fractions. So I want you to put the line down the middle of the equation, and we're going to solve it two different ways. The first way that we're going to do is by clearing the fractions. So if we have 2 and 4 as our denominator in this problem, you have to ask yourself, what is the lowest common multiple they have? Well, the lowest common multiple would be 4. So I'm going to multiply both sides of the equation by 4. And let's do the easy side first. I know that this will allow me to cancel out the right side, leaving me with x minus 1. But if I look over here, I have a 4 and a 2. This doesn't just cancel out. This is a way to think of cross-canceling. So if I reduce this product, I could say 2 divided by 2 is 1, and 4 divided by 2 is 2. I'd be left over with the 2. So this really means 2 times this quantity x plus 3. So it doesn't just cancel out like how it did on the right side. I'm kind of left with some distribution. So what is 2 times x? Well, that would give me 2x. And what is 2 times plus 3? That would give me a plus 6. Now I still have the variables on both sides of the equation, but I'm not dealing with fractions anymore. So ask yourself, do you want to move the 2x to this side, or do you want to move the 1x to the left side? What number's smaller? Technically 1x is. So I'm going to subtract 1x from both sides, and in doing so, this side is what would cancel out. I would now have 1x plus 6 equals -1 if I bring it down. So now I want to try to get this 1x that's by itself, and in doing so I would subtract 6 from both sides of the equation, and my solution, I'm probably running out of room on the screen, would be 1x equals -7. That would be our solution. You can divide both sides by 1 if you want to, but remember 1x is what we were trying to get, so our answer for that should be -7. Alright, so the other way that I could solve this same problem is with a skill that you probably learned last year called cross multiplying. Don't get it confused with cross canceling, which is what I did in the last problem when I distributed that 2 to x plus 3 when we were really multiplying by 4. So this is very similar, but this is cross multiplying, and you probably remember cross multiplying means you're going to take this stuff and multiply it by each other, and take this and multiply it by each other. So if we do that, I would get 2 times the quantity x minus 1, bring down that equal sign, and I would get 4 times the quantity x plus 3. So both ways, for both sides, we're doing distribution because there are quantities that are our numerators. So if I do the distribution, I should get 2x minus 2 equals 4x plus 12. Now I do the same thing with trying to get the variable by itself. So I'm going to bring the 2x to the right side because 2x is the smaller number. Subtract 2x to both sides. This side on the left cancels out, so I'm left with -2 equals 2x plus 12. See if you can solve the rest of this problem by yourself. You have to isolate this 2x first. So what's on the right side with that 2x? The plus 12. So you're going to move that, see if you can solve for x.